Here's our data set of ages of 89 Academy Award winning actresses. This is all of the Academy Award winning actresses. I found this data on Wikipedia in 2016. You can see I've listed all the ages in ascending order, and the purpose of this video here is we'd like to make a frequency distribution table for the data set using 7 classes. So let's get into it. What's a frequency distribution table? Here's an example of one right here. It's a table that summarizes or classifies a sample data set or a census into a 2-column table in which the first column is a list of classes or numeric intervals, and the second column will be a list of frequencies. This will tell you the number of entries that are in each numeric interval. For example, in this first class, or this first numeric interval, you've got the numbers 1 through 5, and you can tell that for the data set that this table is associated with, there were 5 entries in the sample that were numbers between 1 and 5. The second class is the class or the interval between the numbers between 6 and 10, and you can tell there were 8 numbers in the sample between 6 and 10. 6 numbers in the sample were numbers between 11 and 15. 8 numbers in the sample were numbers between 16 and 20. 5 numbers in the sample were between 21 and 25, and so on. Now notice each one of your classes has a lower class limit number. That's the first number listed here. And each class also has a upper class limit number. So for the first class, the lower class limit is a 1. For the first class, the upper class limit is a 5. The class width is the distance or the difference between any 2 consecutive lower class limits or any 2 consecutive upper class limits. For example, you can tell that if we subtract 6 and 1, we're going to get 5, and this will be equal to the class width. You can take another pair of lower class limits, say 16 and 21. You can subtract the 2, and you should get the class width as 5. You can take, on the other hand, any 2 consecutive upper class limits, say 20 and 25, and subtract the 2, and this should always be equal to class width as well. Okay, so let's go ahead and do a table for our data set. And how are we going to do that? Well, the book tells us it's a 5-step process. So first thing we want to do is decide on the number of classes we want to use, then find the class width, and then use that class width number to find the class limits. Then we're going to make a tally mark for each entry in the row of our appropriate class, and this is a step you may be able to skip if you've got your data set sorted in ascending fashion. Then the 5th step, or the final step, is we're going to count our tally marks to find the total frequency for each class. Okay, so let's get into it. First thing we need to do is decide on the number of classes we want to use, and of course the problem tells us to use 7 classes, or that's what usually the textbook will do as well. They'll tell you what number of classes to use on a problem of this flavor, but as a researcher or in practice, what you will do is you'll be the one deciding the number of classes, how many classes to use. We are told to use 7. Okay. So now the next step in the solution is we want to find the class width. And the class width is found with this formula. Class width is always equal to the maximum minus the minimum divided by the number of classes. So then for our problem, these numbers would be, well, let's go back up here and look. The minimum is 21, the maximum is 80, okay. So that is going to give us 80 minus 21. And then we want to divide that by 7. Okay, so we're getting 8.42 and some change. So what we need to do is round that number up. Always round the value of class width up to the next whole number. And so this goes against the standard round off rule. And this is something that you've got to keep in mind now. We're always rounding class width up to the next highest whole number. Okay, so now we're ready to do steps 3, 4, and 5. We want to make a label this first column here, classes. This will be age classes or age intervals, right? And our second column label will be frequencies. So now we want to do step 3, find the class limits. So write down the class limits. You can use the minimum data entry as the lower limit of the first class, or you can use a value that's more convenient than the minimum. So our minimum value was 21, but it might be more convenient to use, say, 20. Now you may be tempted to write down the upper class limit number of this first class, but what we need to do is instead find the remaining lower class limits by adding the class width to the lower limit of each preceding class. So when I add the class width of 9 to 20, I get 29, the next lower class limit. I then want to add 9 to that, add 9 to 29 to get the next lower class limit of being 38, add 9 to 38 to get the next lower class limit of 47, and so on. We would carry this process on. Something I'm noticing here, though, is that it may be more convenient for us to select a class width of 10. That way, this second number here, the second lower class limit number, would be 30. The third lower class limit number would be 40, and so on. So let's go ahead and make the decision to change class width to 10 because it makes more sense to do so. Okay, so now if we decide to have class width be 10, this second lower class limit will be 30. The third lower class limit will be 40. The fourth lower class limit will be 50. Then we add the class width of 10 to 50 to get the next lower class limit, and then 70 would be the next lower class limit, and then finally the last lower class limit would be 80. And this gives us 7 classes, okay? So now if you see the maximum, or recall that the maximum is 80. Is it 80? Let's see here. Yeah, it was 80. So that means we are going to have one entry in this last numeric class. Okay, now we're ready to write in all the upper class limits of each class. And keep in mind, classes are not allowed to overlap. So this means we cannot let this number be 30. For if we did let this number be 30, suppose you have a data entry in the sample numbered 30. Which class would it belong to? Some people might say it belongs to one of the two classes, one of the two first classes, or some people might say it belongs to both. But we need to avoid the ambiguity of that, and so for that reason we're not allowed to have classes overlap. So there should be a gap in between your upper class limit of your first class and the lower class limit of the second class. So what we're going to do is just subtract 1 from 30 to get 29 for the upper class limit. Now when these actresses are reporting their ages, they're truly recording them as being, if you look on Wikipedia, the ages will be, say 29 years of age and then 340 days. We're going to ignore that and just take our sample data to be just the age numbers. So it's okay to have a gap between 29 and 30 then. So now we should be able to add 10 to this number to get the next upper class limit, which will be 39, of course. And we're adding 10 to each one of those upper class limits to get the next upper class limit. Or alternatively, if you just want to subtract 1 from 60, you get the previous upper class limit. Subtract 1 from 70, and we'll get the next upper class limit, and so on. Okay, so now we're going to go ahead and proceed with steps 4 and 5. We can really skip step 4 because we have our data set sorted. We can now just do a visual inspection and make sure, do a visual inspection and count the number of entries in each interval. Okay, here's our data set on the right, and let's go ahead and count the number of entries in the sample that are numbers between 20 and 29. Okay, I counted 31. So the frequency of that first class should be 31, representing the 31 entries in the sample, which are ages between 20 and 29. So now let's count how many actresses in the sample were aged 30 to 39. 5, 6, 7, 8, 9, 10. So I'm getting 34. And now let's count how many actresses were aged 40 to 49. 1, 2, 14. Okay, so 14 for that class. And then how many actresses were aged 50 to 59? There were 2 of them. How many actresses were aged 60 to 69? Let's see, 1, 2, there were 6 of them, okay. And 1 actress aged between age and 70 and 79. And 1 actress, Jessica Tandy, 80. So there's our frequency distribution table for the ages of the 89 Academy Award winning actresses. Okay, so one thing we need to do to double check this result is we need to sum up or add up all of these frequency numbers here, and that sum should give us the sample size 89. So now let's go ahead and do that.